True Projects. In this video, we are going to explain a project entitled as Ad Click Fraud Detection using Machine Learning and Deep Learning Algorithms. So, before getting into the video, let me give you a brief description about the project. It is a modern approach to identify and prevent fake clicks on online advertisements. Ad click fraud happens when automated bots or malicious users repeatedly click on ads to generate false revenue or drain advertisement budgets. Traditional detection system based on fixed rules often fails because fraudsters constantly change their techniques. Coming to the abstract states that click fraud is a serious problem in online advertising that occurs when fake or automated clicks are generated on ads, wasting advertising budgets and lowering the efficiency of marketing campaigns because these fraudulent clicks can look very similar to genuine ones. Detecting them requires sophisticated analysis and modeling techniques. This study focuses on developing and comparing different machine learning and deep learning models to accurately distinguish between fraudulent and legitimate clicks. A key part of this process involves feature engineering and feature extraction, which helps identifying suitable behavior difference between real and fake interactions. For example, variations in click timings, device information, or user patterns. To enhance model performance, recursive feature elimination (RFE) was applied to select the most relevant features and remove redundant ones. The existing system states that in today's online advertising world, most click fraud detection systems still rely on basic rule-based methods. This system watches for things like too many clicks from one IP address, unusual click-through rates, or repeated clicks from the same device. While they can catch some type of fraud, they often miss more advanced schemes that looks just like real user activity. As a result, real clicks sometimes get flagged as fake, and fake clicks can slip through. Another problem is that this system reacts only after fraud happens instead of preventing it. And with online traffic growing so fast, manual settings and managing these rules just isn't enough anymore. That's why we need smarter, data-driven solutions to detect click fraud more accurately and efficiently. Coming to the proposed system or the base paper work. The proposed system enhances click fraud detection by advancing beyond traditional machine learning and deep learning methods. Instead of relying only on models like decision tree, random forest, or basic CNNs, this approach introduced a convolutional neural network integrated with an attenuation mechanism. This attenuation layer enables the model to focus on the most relevant features in click behavior, helping it detect suitable and complex pattern that indicates fraudulent activity. By emphasizing important details and understanding contextual relationship in the data, the attenuation-based CNN can more accurately differentiate between genuine and fraudulent clicks. This improvement leads to higher accuracy, better precision, and overall stronger performance, offering a more intelligent and reliable solutions for combating click fraud in online advertising. Coming to the dataset, the dataset used for this study contained detailed information about user click activities collected from the online advertisement platforms. Each record represents a single click event and includes multiple features such as timestamp, IP address, device type, browse information, ad category, click-through rate, that is CTR, and conversion status. These features helps capture both user behavior and technical patterns associated with each click. This dataset is also included labels indicating whether a click is fraudulent or legitimate, enabling supervised learning for model training. Before model development, the data underwent pre-processing steps such as cleaning, handling missing values, encoding categorical variable, and normalizing numerical features. This ensured data quality and consistency. The dataset was then divided into training and testing subsets to evaluate model performance. Overall, the dataset provides a comprehensive foundation for detecting suitable difference between genuine and fraudulent clicks, supporting accurate and reliable model predictions. Coming to the novelty or extension or improvement or enhancement. Firstly, in this project, as an extension, we deployed and implemented three advanced deep learning models, LSTM, GRU, and a hybrid LSTM plus GRU model to capture sequential click patterns and improve prediction accuracy. These models achieved outstanding performance, reaching 100% of accuracy in ad click fraud detection. Additionally, we designed an ensemble model. Additionally, we designed an ensemble machine learning model using a noting classifier that combines XGBoost and bagging with decision tree, further enhancing reliability and robustness. Then, to improve the interpretability, we integrated explainable AI techniques such as LIME and SHAP, which helps visualize and explain the influence of each feature on the model's prediction. For testing, we developed a Flask-based user interface where users can click on dummy ads, allowing the system to capture input features and dynamically predict whether the click is fraudulent or genuine. Since the base paper dataset was not publicly available, we used a Kaggle dataset with fewer features and therefore did not apply recursive feature elimination. Despite this limitation, our models demonstrate expectational accuracy and performance through careful pre-processing and fine-tuning. Coming to the flow of the work, the project began by importing all the required Python packages and libraries needed to data analyze, visualize, and model building. Next, we explore the dataset, which is an ad click fraud dataset obtained from Kaggle. During this step, we understand the structure of the data, identifying key features, and check for missing or inconsistent values. Then, data pre-processing. In the data pre-processing stage, we clean the data set by removing unnecessary columns, handling null or missing values, and deleting the duplicate records. We also apply label encoding to convert categorical data into numerical form so that machine learning and deep learning models can process it efficiently. Data visualization. After the data pre-processing, we perform data visualization to gain insights. This includes plotting the distribution of classification outcomes to see how balanced or imbalanced the classes are and creating a correlation matrix to identify relationships between the features. Once the data is balanced, we split the dataset into training and testing, sees in an 80 is to 20% ratio, where 80% is used for training the model and 20% is used to test their performance. Build the classification model. The base models includes both deep learning models and machine learning models. As a part of our extension work, we developed advanced deep learning models along with an ensemble voting classifier combining XGBoost and bagging with decision tree to further improving accuracy. Each model is evaluated using performance metrics such as accuracy, precision, recall, and F1 score. We also generate a classification report, confusion matrix graph, and ROC accuracy for a detailed performance comparison. After evaluating, we compare all models based on their scores and visualize the results using comparison graphs. The best trained model is then saved by deployment. To make sure the system more transparent and interpretable, we integrated explainable AI techniques such as LIME and SHAP, which help to explain the impact of different feature values on each prediction. Coming to the front end, for the front end, we developed a web interface using a Flask framework, integrated with SQLite database for user registration and login functionality. Once logged in, user can click on sample advertisement. When an ad is clicked, the system automatically captures the pre-processing input data related to the click and then uses a trained model to predict whether the click is fraudulent or genuine. Each ad click generates different input values, so the prediction may vary each time. Finally, the prediction results is displayed instantly on the front-end dashboard, providing a real-time demonstration of the model's performance and usability. The algorithms used are logistic regression, decision tree, random forest, KNN, ANN, gradient boost, light GBM, XGBoost, navy bias, deep learning with CNN, DNN, RNN. Coming to the requirements, we have hardware requirements and software requirements. Hardware requirements consist of operating systems Windows only, processor i5 and above, RAM 8 GB and above, hard disk 25 GB and above. Software requirements, application framework is Anaconda, primary language is Python, front-end framework is Flask, backend is Jupyter Notebook, database is SQLite 3. Technologies which we use to build the front end are HTML, CSS, JavaScript, and Bootstrap 4. To execute this project, first we need to open the code folder which contains the project source code files. Project code folder is a complete package of your project code base containing everything you need to develop, test, or deploy your application or model. Static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. Template folder. Template folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. App.py file. This .py file contains the information related to the front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. These are the model files which contain algorithm information which will be loaded into the project code during the runtime. Notebook.ipynb. This is a Jupyter Notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute the code in individual cells, making it a popular choice for data science. Signup.db file. This file is a database file used to store user information. Now, coming to the execution of the project. Firstly, you need to copy the path of the code folder from the address bar of the file explorer. Then, open Anaconda prompt. Using the command cd followed by a space and then paste the copied path. This command is used to change the current directory of the code folder's path. Compile the app.py file by using the command python space app.py in the Anaconda prompt. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address. Now, copy the link provided by the Flask framework and paste it in any web browser. I prefer Chrome. Paste the path, then click on Enter. The home page of the project should now be displayed in the browser. This is a front end built by using the Flask framework. So, this is a web page of the project displayed on the browser. In this page, we have Home button and Register button. Now, click on Register button so that the login HTML will be opened. Here, we need to give the details and create an account for user authentication, like username, full name, mail ID, mobile number, and a password. Then click on Create an account so that all the given details are stored in signup.db and the login HTML will be opened, where we need to access the application by username and password. So here we need to enter the username and password. Then click on Sign In. The prediction page has been displayed. In this, we have Home button, Ads button, Graph button, Notebook button, and Logout button. Now click on Ads button so that some of the ads will be displayed. Now click on any one ad. Based upon the clicks, we do the output. Based upon the clicks we do, the output will be predicted as legitimate activity, like it is a low risk legitimate. The parameters of detected output are click analysis, mouse tracking, timing analysis, and risk assessment. Here, the detailed analysis report has been given, like how many legitimate features are there, medium risk is of 1, high risk is of 2%, and confidence is of 79%. This is the overall summary of the clicks. Here we have view ads again. So again, some of the ads will be displayed. Now click on any other ad. Now it has been detected as fraud detection. It is very high risk detected. On the parameters like click analysis, mouse tracking, timing analysis, and risk assessment. The fraud has been detected. The detailed analysis report is given as legitimate features are 10, medium risk is of 1, high risk is of 3, and confidence level is 71%. And this is overall summary of the click. Here we have print report, download the analysis or share the results. Now click on graph. When you click on this graph button, some of the data has been visualized. Data visualization means representing the data in graphical or visual format such as charts, graphs, maps or dashboards so that patterns, trends and insights can be easily understood. Firstly, we have sample outcome. Sample outcome refers to the example results or visual representation created from a dataset to illustrate key finds or patterns. Next, we have class distribution before and after SMART ENN. It refers to the comparison of how balanced the dataset classes are before and after applying the SMART ENN technique. Before SMART ENN, the dataset may be imbalanced, means some classes have far more samples than others. After applying the SMART ENN, a hybrid method combining SMART synthetic minority oversampling technique and ENN edited nearest neighbors, the data becomes more balanced. SMART generates synthetic samples for minority classes while ENN removes noise or ambitious samples, resulting in a cleaner and more evenly distributed dataset for better model training and prediction accuracy. Next, we have correlation matrix. A correlation matrix is a table that displays the relationship between different variables in a dataset using correlation coefficients. It helps identifying which variable are strongly or weakly related to useful for feature selection and data analysis. Next, we have confusion matrix or ROC accuracy. Confusion matrix shows how well the model classifies each category by comparing actual versus predicted values. ROC accuracy graph. It shows the model's ability to distinguish between classes with higher AUC, indicating better performance. This is the accuracy graph. Accuracy graph shows how correctly the model predicts overall outcomes. On the x-axis, we have algorithm names. On y-axis, the accuracy has been displayed. Precision graph. It shows how many of the predicted positives are actually correct. Same way, we have x-axis the algorithms and y-axis predicted for precision graph. Next, we have recall graph. Shows how well the model identifies all actual positive cases. X-axis we have the algorithms and y-axis we have recall graph. F1 score graph. It shows a balance between precision and recall in the model performance. In x-axis we have the algorithm names and y-axis indicates F1 score. And finally, we have summary of fraud. It shows how each features in the dataset influence the model prediction for fraud detection. It visualizes the importance and impact of different features, indicating which factor contributes most to identify fraudulent or non-fraudulent cases. Now, click on Logout. So finally, the project detects ad-click fraud using machine learning and deep learning techniques, ensuring accurate detection and improving the security and efficiency of online advertising. This is all about your project. Thank you.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.